Well, dimensional analysis is used to solve problems. It's a method that's used quite a bit like stoichiometry that you learned last year. And it's the idea that units can be canceled like numbers. So we're going to go through a few examples on how to do this, just to kind of a refresher from stoichiometry last year. On my trip to Elk Rapids last weekend, we traveled 170 miles in 3 hours. What was our average speed? Well, some people have a hard time. They know they have to multiply or divide. They're not sure what by what. So looking at this, you know your speed is what? What do you measure speed in? Well, miles per hour. So we know we have to get miles over hour. So if you look at your numbers, we have 170 miles and we have 3 hours. So if we know we need miles over hours, you take the 170 miles and put that on top and divide by the hours, 3 hours. So let's go ahead and do that. So we have 170 miles in 3 hours. And you take the top and divide it by the bottom. And when you do that, you get 56.6667, goes on forever. All right, so your units, you know, are miles over hours. I'm going to abbreviate. And if you round to sig figs, 3 only has one sig fig, so we have to round this to 60. You got one sig fig with a 5, you look behind it, it's a 6, so you round it up. Got to put the 0 in for a placeholder, so it's 60 miles per hour. So that's how we use dimensional analysis to solve a problem. We knew the units, worked backwards to figure out the number. Okay, so we're going to use dimensional analysis again to figure out how to convert 2.3 kilograms to grams. So what you know, you always put on top, just like in stoichiometry. You started with the one you knew, the one you had the number for, and that goes on top. So some people feel comfortable drawing the line, some people have to put a 1 underneath it. Doesn't matter, however you want to do it. Well, you know you want to get to grams, so you know kilograms has to cancel out. So in order for that to cancel, you have to put kilograms down low. That goes back to math. You'll have grams on top, so you can get to grams. And it's a good idea to get in the habit to put 1 by the bigger unit. So kilo is a lot bigger than a small gram. So we'll put 1 there. And that way you're not dealing with decimals. You know that 1,000 grams are in a kilogram, because that's what kilo means. So that's a version of 1 right here, 1 kilogram to 1,000 grams. So what you do then is you multiply across. What's 2.3 times 1,000? Well, 2,300. On the bottom you have 1 times 1. You can see the kilograms cancel, which is great because we want grams. So looking at sig figs, we know this is exactly 1,000 grams, so we could have put a decimal there. So this has infinite sig figs. So you look at the number given to figure out how many sig figs there are. So there's only 2. So it's 2,300, and that number only has 2, so it's perfect. And that's our answer, 2,300 grams. Okay, let's go ahead and try a trickier one. We have 1 mile, and we're going to convert it to meters. And before I start this problem, I'm going to give you a conversion factor that you probably don't have in your head, but 1 meter is 1.1 yards. So we're going to use that conversion factor, and that's probably not one you have in your head. All right, so look at this. We got 1 mile. We're going to put that on top. All right, so you can draw your line if you want to, whatever you're comfortable doing. We know we need miles to cancel, so I'm going to put that down low. And what do we know about miles? We got to get to something smaller, we know, because we have to get down to meters. Well, a lot of you know in your head that 1 mile is 5,280 feet. So great, we moved on to something else. We got the miles to cancel. We're not there yet. We need meters. We got feet. So we got to go a little bigger. So we got feet down here. Well, what do we know about feet? We know 3 feet make up 1 yard. So we'll put the 1 by the yard. And there's 3 feet in a yard. You can see the feet cancel. Notice I'm not multiplying anything yet. Nothing. We're just writing conversion factors. All right. Now I'm at yards. I know I need meters. Well, look at this conversion factor I gave you. You know you have meters here converting to yards, so we can do that. We got that conversion. 1 meter, so we're going to put the 1 by the meter, is 1.1 yards. And we're going to go ahead and cross out the yards. Okay, we're left with meters, so now we know we can stop. To get your final answer, you got to multiply across 1 times 5,280 times 1 times 1, and down below you have 1 times 3 times 1.1. So you take your top number after you multiply across and your bottom number, and you divide, and you get 1,600 meters once you do your sig figs. So you may need to take a minute to calculate that, but you'll see in the end that it's close to 1,600 meters, and you should have 2 sig figs because you have 2 in the beginning. Okay, this is the last example here. We're going to go ahead and work with this 7,600 meters per second. And this is about how fast a satellite travels, and we want to see how many miles per hour this would be. So make sure you leave a lot of room here because this is a longer one. We're going to go ahead and write what we know on top, 7,600 meters, and it's per second, so second actually goes down here, per second. If you want to put a 1 there, you can. So it's traveling 7,600 meters per second. Well, that doesn't mean much to us. We know miles per hour more because that's what you're used to using. So we have 2 things to convert. We have the meters we have to change to miles, and we have the seconds that we have to change to hours. So we got to change 2 things. You're just going to change one at a time. So let's focus on this top number. We're going to change that 7,600 meters to miles. So we need to put meters down here, so it cancels. And what do I know about meter? Well, from the problem above, I know yards. I know 1 meter is 1.1 yards. And great, I'm at yards, but I gotta get to miles. So I have yards that need to cancel. I'm gonna put that down low. And then on top, I can go from yards to feet. I know in 1 yard, I have 3 feet. And I want the feet to cancel, so I'm going to put that down low. And I know that in 1 mile, I have 5,280 feet. All right, great. Now I'm at miles, so I know I can stop there because I took my meters and made it to miles. However, I still have my seconds, and I got to change that to hours. So you got to pretend like, no, this is here right now, so it's not in the way, but we have seconds and it needs to cancel, and it's on the bottom. So that means now I got to put seconds on top. And I got to take the seconds and convert that to, well, I know minutes. I got to get bigger here. So I know there's 60 seconds in 1 minute. So now I have miles per minute. That doesn't quite help me out. I got to do it one more time. I want minutes to cancel, so I got to put minutes on top. And I want hours on the bottom. In 1 hour, I got 60 minutes. So now I'm at miles per hour, which is great because that's what I want to get in the end. Now, it's just a lot of multiplying and dividing. So you got all the numbers on top, 7,600 times 1.1 times 3 times 1 times 60 times 60. And that number goes on top. Multiply all the numbers on the bottom. 1 times 1 times 1 times 5,280 times 1 times 1, and that number goes on the bottom. And then you take the top and divide it by the bottom. Well, when you do that, you get 17,100 miles on top per hour. You can see that's what you're left with, so it makes sense. That's your unit, miles and hours. And I only should have 2 sig figs because that's all I have in the beginning. So this would round to 17,000 miles per hour. And that's your final answer. So that concludes Objective 5, and now you know how fast a satellite travels. It's going pretty fast.